Okay, good. All right, so hello everybody. I'd like to welcome you all to the last presentation of GWT.create. I'm James Nelson. I work for Appian Corporation, and the project I'm showing you today is ColliDE. This was built at Google Atlanta, and it was open sourced by them when their office was sadly closed. Did anybody here note that it would, or get the blog post about ColliDE or check it out? Anyone? One person. Excellent. Okay, so I was one of the people who saw this and saw that inside of it, it uses components of Google Wave to perform the real-time collaboration and was instantly hooked. Anything to do with Google Wave, I like to jump on and play with it. The walk-around open source project was another thing I played with, but it didn't really have any support for anything I wanted to do. ColliDE, on the other hand, had built-in HTML, XML, JavaScript, and CSS autocomplete, syntax highlighting, many other features that made it very good as a remote file explorer. So if you have your web server is running and you want to be able to quickly search through your files, pop something open, make a few changes, see how it looks, it basically did all of that out of the box. Since then, I've taken it and have been turning it into my own little personal GWT control panel. So aside from ColliDE, I also build other GWT tools. Super Dev Mode has been my little project. I have a Maven plugin which will allow you to deploy Super Dev Mode from your Palm, which will be getting integrated into ColliDE soon. The GUI on that one is not very nice, so I'm going to leverage the existing framework here. There are a bunch of other features, but I will get into those as the slides come. So first of all, what it is today. What it is right now is essentially a glorified, simple file editor that has, I need to apologize. My Linux desktop doesn't stream presentations very well, so I had to export this and use it in LibreOffice, which has clearly made my slides a little bit unreadable. So the important stuff is there. I'll post nice ones later. So anyway, the existing implementation, when I got it, it was using a pre-release version of Elemental. It was basically not ready for release, but because the office was closing, they had to release it. It was using a Google private backend. So what they did was they cut that out and used VertX instead. And show of hands, anyone used VertX before? Written by Tim Fox? Okay, it's basically a clustered Java server that uses Netty to stream things with sockets. So it's very powerful for multiple JVMs to communicate with each other. A little bit of overkill for what I'm using here, but it's actually highly performant given multiple machines. So in the future, as more people are actually using this to perform compiles at the same time, you don't want my compile and your compile sharing the same RAM, because that's not going to go very well. Essentially, the actual pieces that I've added are all GWT-centric. So I'm going to try to focus mostly on those, but I will show you all of the existing tools that come with it as well. So I'm going to get right into that as soon as I can. Yeah, sorry. Oh. Anyway, so I also want to mention that ColliDE is not a replacement for your desktop IDE. You're not going to throw away Eclipse or IntelliJ. This is a supplement to your existing platform, not a replacement. So don't expect this to be your ace in the hole that you're going to use to do everything, but the things it does do, it does well. So in the past, what came with it was the real-time collaboration, obviously. The awesome box, as they call it, is a very simple search for any kind of file that is available on your web server. Wherever you deploy ColliDE, it indexes all the files, sends them to the client, and allows the client to search quickly. It will sync any files that you change so that I see them immediately, and vice versa. The internal use of Elemental actually means it has extremely high performance because it's using native DOM for everything. There's not a single widget. There's almost no array list. It's almost completely Java util free. I would like to make it 100% Java util free, but there are a few things, window class, for example, in GWT that uses it. I've been talking to team members, and hopefully we can make everything use low-level JavaScript. So the auto-generated DTOs, those are kind of nice. It uses WebSockets to stream. So instead of actually maintaining your own DTOs, you simply define the interface. The client gets low-level JSON. The server uses JSON, and it streams very quickly. So with that, I will get right into the demo. And this is a live server link, which I'm going to leave up. But for here, I'm using localhost because my VPS is kind of slow. So over here, I've got two windows. It's a little crunched on the screen, but both of these guys are editing the same file. So you can see that as I'm typing on one screen, it comes up in the other. So that's pretty much what you would expect. Has anybody looked into the Google Wave document model or the Google Docs conflict resolution model? Okay. So I'll give you guys a quick run through. How it works is every document is a range of text, and whenever I perform an edit, it basically says he went to position 436, typed in these characters, and it became this document. If someone on the other end is at position 312 and types something in, what the server does when it looks at it, it looks at both of the original documents to see what the edits are, and then it just applies them over top of each other. So if Bob, for example, makes his edit in the same place that James does, then what the server will do is it'll apply Bob's changes on top of James's and James's changes on top of Bob. And in the end, both guys get the same document back and everyone stays in sync. So that's provided for free from the Wave project, now Apache Wave. There is a tool, Redoma, that actually is using a fully fledged Google Wave server. So if anyone is interested in that, I can provide links. They're a commercial product, however, so if you want your own Google Wave, you're still going to have to build it yourself. Another handy feature, of course, is the Awesome Box. So I can just type in anything, pop open the file, do a simple search within the file, except my keyboard shortcuts collide with this particular browser, so I won't show you that. The syntax highlighting is all provided by CodeMirror, which is actually JavaScript, so it's not 100% GWT, but it does give you an API to be able to define your own syntax to perform syntax highlighting. So it's not simple, but there are plenty of examples with languages you already know. So if anyone has any expressions, languages, or custom languages you want to have a simple editor with syntax highlighting, great for that. You should be able to pull out what you need without taking the rest. It's not completely modular, but I am working to Mavenize it so that if you do want to borrow bits and pieces, you can go ahead. So out of the box, there wasn't a whole lot more really going on. There were a lot of other features that were stripped. There had been a local debugging extension, which unfortunately doesn't go anywhere, so that's been removed. This is a snapshot from the old version. So all of this stuff, unfortunately, depended on internal Google stuff that didn't make it into the open source project. So we'll go ahead and close these guys and pop back open to here. So now, present. I've went and updated all of the dependencies. So now we're using 2.5.1 with the newer Elemental. And before this presentation, I'd considered abandoning Elemental because it is actually a little difficult to use with UI Binder. But given the future with web components and JS interop, it's looking like I might be in a sweet spot to play with all the new stuff. So if all of that works out, I'm going to get a pre-release branch from Ray and essentially build pieces like a GWT compiler as a web component. So if you want to be able to drop a compiler into your local development environment so that you don't have to use a bookmarklet, or if you want to, if you have some kind of complex build script to get your dependencies, you'll be able to bundle that into your tools. The plugin system that is added essentially allows you to create your own plugin that is isolated from everybody else. So every server plugin is going to have its own class path and its own namespace for the WebSockets. And the client side, you'd be able to add file extension based plugins or a little button in the bar for your own plugin. So the only one that works now is the GWT recompiler. The next one on the list is Ant, because this uses Ant build script. So I would like to have it be able to because right now it can recompile the front end and hot swap it, and the next step is to be able to recompile the back end and hot swap it as well. And because VertX uses lots of isolation, it's very simple to shut down one piece of the server, reload with a new class path, and carry on where you were. There's no state whatsoever on the server, so it'll be very simple, just haven't quite got to it yet. So the GWT compiler stuff, we'll get to that in a second, because that's the fun part that I'm sure everyone's more interested in. Another experimental feature is an @GWT annotation, which essentially I'm only using right now for test modules, but this allows you to define your dependencies for a particular unit test, so that if you have a hierarchy, for example, of packages, you can have this on a package annotated with whatever that package needs, and then every JUnit for unit test inside of that package will have all of those dependencies. No GWT.xml to manually manage. I'd like to extend this to actually possibly replace GWT.xml, because with the coming changes to the incremental compiler, it's actually more performant to have lots and lots of modules, because each one will be compiled separately. So that'll be able to leverage incremental compile and give you a 2-second super dev mode refresh. So with the deprecation of regular dev mode, this may become an important tool. The XAPI is the other open source library that I work on. That is where anything like the GWT recompiler that I'm going to extract and make available to public use will be put, because this is a highly modular Maven project which allows you to pull in what you need. So GWT reflection, there's about 95% support for the entire reflection API. That's another talk entirely, but if you are interested in having reflection, or if you have a dependency that has reflection and you want to be able to use that without having to hack anything, do let me know. My emails will be at the end. Magic method injection is another little Easter egg I threw in there. I basically looked up where GWT.create works and made it pluggable. So if you want to make your own magic methods like GWT.create, for example, if you want to access constructors that have parameters, this allows you to take a particular method and replace it in the compiler. So whenever Ray talks about compiler magic, that's usually what is meant, is that it's a magic method. It's a little hairier than regular generators, but for the most part, what I find is you can use a regular generator and then simply generate the whole class and then pick out the one method that you need and inject that. So that's kind of included for free in ColliDE, but also available publicly without ColliDE. The JUnit4 test support is essentially a generated host page that allows you to take any JUnit4 test, run it in GWT, and also debug it in the browser using super dev mode. So rather than running your test cases in Java, or even dev mode in Java, which is a different environment than your code actually runs in, this ensures that you're testing exactly the environment the client is experiencing. So I'm not a huge fan of mocking. I know it's the de facto standard for when you need to plug stuff in. I like integration tests. So for me, this gives me a chance to test my widgets in the browser to see what they're actually doing. So I guess I will show you a bit of that. I'll start with the JUnit support. So this isn't exactly the prettiest display here, a little small, but actually I need to open the JUnit test. So my JUnit test is testing that JUnit works. So it's pretty simple. You know, before class is making sure before class is doing before class stuff. Nothing really important to see here. So over here we have the compiler log. This is the GWT recompile controller here. It's a little squished, you can't really see much of the stuff. This over here is the actual running GUI for it. So how this works is each test module in my test package has the GWT annotation on it so that actually the test package has the GWT annotation that provides the dependencies, and everything else is done automatically. So let's go down to the JUnit test here. So we can see everything passes, everyone's happy. Let's go ahead and make that fail. So hit draft compile. Hopefully, oh, there we go. Recompiling. And I have it so that the failed tests will go to the top of that particular test, but I don't have it so that a failed class will go to the top of the list. But here we can see, yep, it's failed. Something went wrong. I wonder what it could be. So let's pop open our source maps, and oh, that's so squished. Okay, we'll go over here and let's rerun our test. And oh, look, we get a breakpoint. So why I got a breakpoint here is because I have the pause on all exceptions set up. So for anyone who's actually looking into super dev mode, this is kind of what the debugging experience is like. So here we have the call stack. You can see there's quite a bit of work done to create a stack trace. So anyone who's using exceptions to do signaling in your app, this is a good reason why you shouldn't do that. Very deep call stack. All right, so test before. Here we go. So assert true, not before. Obviously, that's not what we want. This does allow you to see what is in the scope of the variables. It might be nicer if I showed you more object-based stuff, but I'll actually maybe step back a little bit further so you can see what it's like to be debugging. So run test, here we go. Go ahead and get rid of this guy. Yeah. Oh, it's, yeah, there we go, perfect. That is a bit of an annoyance sometimes, is that it's actually easier to just close the console and get rid of all your errors at once. Anyway, let's go ahead and click this again, grab our breakpoint, and now we can drill into JUnit 4 runner. We don't really want to see it set up. And then inside of this, I'm essentially creating a runtime view of the methods. Because I have reflection support, I'm literally grabbing the methods off the JUnit 4 class and putting them into a GUI generator that just pops out this very simple thing. There is support for creating your own widgets, but it's too ugly to demo at the moment, so I didn't include that. Anyway, that lifecycle is just actually pulling off all the methods. So you can, as you see here, this is the actual source of the class in the actual Java class. The JavaScript that it's running is compiled into JavaScript, but this is the actual meat that provided the meal. So that basically allows you to do any kind of in-browser unit testing. This will be shined up a little bit, and you won't have to use my GUI, I promise. I'm a developer, not a designer, so don't mind that. I guess the next thing I'll show you here is in a regular Hello World application, while I'm developing, I can go ahead, make a change, click the button. I need to change that tab. So recompiles, quick reload. Oh, really? You're not? How embarrassing. Let's go ahead and refresh the page. Hit draft compile. This does support draft compile and full compile, so both of those essentially just use the GWT compile model that is sent to the server. On one backend, it runs the recompiler, on the other one, the full GWT compiler, so that way, if you do want to do it in place full production compile, because some bugs only happen when you obfuscate your code. So when those do happen, using super dev mode isn't going to find it, or even draft mode isn't going to find it. So that's what we want there. Looks like I'm going to have to restart the server. I'll be right back. Demos, it happens. So this is a fresh compile, a little bit slower. The first one's always a little bit slow. Little Easter egg there as well. I'm actually printing out the code that uses reflection. So this is just because I have the debug on here, so I want to debug everything. This is creating about double to triple the boilerplate for a standard class, so you don't want to use this for unless you really need it. There is lightweight reflection support, so you can do reflection-like stuff without actually a method object, but as soon as you want a method object or a field object and annotations, you're going to get a lot of generated code. So in order to help with that, obviously it's nice to see the generated code so you can figure out what it's doing. Anyway, go ahead, make our changes, hit recompile, wait a few seconds, changes. So pretty standard stuff. Once again, I dumped more reflection in here just to kind of show it off. So if anybody does want to play with it, this is your out of the box, see what it does, go make your own changes, do your thing. So that's that. And now to the future. So with this, I'm already using ColliDE to recompile ColliDE's own GUI and also a few other little projects that I work on. But my aim here is to actually create a comprehensive developer tool that the GWT community can leverage to basically share all those little things that we've all figured out and have to try to automate and integrate with our existing products. So to start with, obviously using it as a simple front end for remote development, that's handy. But what about your build script? What if you have 100 people at your company and only 3 of them really know what every command in that AND script is? Are you going to have your top developers train the new guy, or are you going to have the top developer build a tool so that the new guy doesn't have to ask questions? This also allows you to put in all your documentation into the tool that does the thing. This allows you to have your documentation and your tools listen to what's happening on the server and detect a common error. If your backend dies and you know what exception happens when your backend dies, your error pop-up can have a button that says, would you like to restart the backend? So that way you don't have to go searching for a document or asking a question. You build a tool that does that for you. So in the future for ColliDE, I'm going to be doing Maven, Gradle, Ant, and Bash. The Bash I already have working in JavaFX that allows me to stream through a Java process. That is not available on the public server because that is a ridiculous security hole. If anybody does have any suggestions on how a person could add an extra layer of security beyond secure WebSockets, I'm all ears. That's the kind of thing that I play with for fun, but I really wouldn't want my company's CI sites to have an open terminal for anybody who has a login. So the element inspector is another interesting little combination of things. Because I'm able to use reflection to look at your class files, the idea is in development mode, you can add an extra run async split point that's going to compile in all of the reflection data for all of your modules, which is going to be probably triple to quadruple your code size. But that also means while you're developing, you should be able to right-click an element and inspect the source code for that element. So that means if a widget is misbehaving, you don't have to go looking for what widget is this. You can just pop open the context menu, select view source, open a source editor, edit that source in the site, click recompile, and see if that worked or not. So that's kind of the development flow that I want, not the development flow I have yet. So if that does interest anybody, once again, open source project, any help is appreciated. So let's go ahead to the next slide. The GWT GUI plugin. This is something I've noticed every time you're editing your view and you have your UI binder file and your CSS and your Java source code. You always wind up switching between files and doing a search, finding the right thing. It would be very nice if you could just pop open a single tabbed editor that has all of those resources with autocomplete and perhaps even pair programming abilities so that if you need to get that, long-bearded guy with all the knowledge to come help you out, you don't have to send him code. You can send him a link and he can just pop open that link and show you exactly what to change and why to change it. The previous version at Google had JGit support to basically integrate with your Git repository. That unfortunately was removed, but one of the developers, Jamie Yap, has graciously agreed to help me out via Hangouts to get that re-implemented, because when you are doing a remote editing session and you want to make a change to CSS, you don't want that change to live on your remote server. You want that change to be committed and pulled back down to your local branch. So if anyone has ever had to meet a spec and wind up doing a bunch of CSS edits in Chrome and then try to trace back down all those changes you made and put them back into the file, and oops, I missed one, this kind of cuts that out and allows you to use the tool to perform the edits, commit the changes, and pull them back down. So that is actually very high on my radar, but not until the GWT recompiler is out there and for everybody to use. The file association plugins, that's basically where I want to do the Java editor. Because it has support for simple languages like JavaScript, CSS, HTML, there's autocomplete for all of those. But with Java, it's a little more complex, and there's a lot more you can do with it because, as we all know, hyperlinking a class so that you don't have to actually type anything in, you just Control-click or F3 or whatever your hotkey is, that would be extremely nice when navigating code. So that is my next big project is going to be that. So another very big one is Ninja Mode, as I call it, where essentially you take the awesome box and the plugins and you hide everything else. So that way you can have this little floating component inside of your app, so that when you're in development mode and you want the access to these tools, you don't have to pull in ColliDE into your app. You can run them separately. If anyone saw the Turducken talk, I think that was done in San Francisco, that's the idea of using separate GWT modules that communicate with each other. So this is going to be something like that, but if a person can use a little bit of Java wizardry, it should be possible to actually use the stack trace deobfuscator to look at another module's classes, or at least to get the source code for those classes so you can inspect them. So that's another little feature there that I've got on my wish list. So, that's unfortunate. That's thanks to LibreOffice, but we'll ignore that. The changes under consideration. There's a number of things that are working, but might be a bit of a barrier to adoption. For example, nobody in this room uses Vertex, and I can promise you it's a different sort of beast. So I don't want to force people to use something they don't know and have to learn. So that would be where adding standard servlet containers comes in handy. And all that I would really need to do is change it from standard WebSockets to either RPC, or if there is an existing WebSocket library that I can use, then just simply switch out the backend. I had considered dropping elemental support until I saw the JS interop and web components talk. So actually, I'm going to be sticking with that. And going forward, basically trying to make every plugin, starting with the GWT recompiler, a web component that you can reuse. So with a standard servlet container and a web component, all you would have to do is add a little snippet of XML to your Maven or Ivy or Gradle dependencies, and you would automatically, you'd also have to add the NoScript or the nocache.js file. So 2 small edits, and you instantly get a embedded GWT recompiler that you don't have to do complicated launches and complicated setup. And you need the bookmarklet, which is another barrier for mobile developers. You don't really have that option. So that is where the actual client-side framework is going to be elemental, and then eventually web components. So build script wizards are essentially what I was talking about, where you have a complex process that maybe a few people in the company know well, and everybody else has to kind of muck their way through it. So take those guys that know it well, get them to spend a week or two, and build a wizard so everyone else can just do the simplest possible thing to get the proper result without confusion. I know I personally wind up spending 2 to 3 weeks of my life going over an Ant build script to really know every single thing it's doing once they get very big with lots of modules. So the editor itself, I'm still looking at using the Ace editor as a possible replacement just because it has a lot of community support. If I do see a lot of people interested in a pure GWT editor, I'll be more than happy to continue pursuing it. But in the interest of not reinventing the wheel, that may be another change that is worth making. So an Eclipse RCP runtime, has anyone done remote, or sorry, the embedded Eclipse environment to leverage their tools? Nobody? Okay, so I've used Eclipse to essentially use the refactoring tools and the JDT to perform Java transformations. So being able to actually embed Eclipse into another Java runtime is actually quite simple. And the idea here is, instead of trying to write my own Java compiling system that has markers and flags and refactoring and all these tools that already exist, simply drop them into the backend and then write a transport mechanism that allows the front end to use those. So once again, instead of reinventing the wheel, leverage the existing tools. The actual pair programming in ColliDE isn't terribly great right now because when I change files, it doesn't let you know that I've changed files. So I would have to essentially tell you over chat or video that, hey, here's the file or here's a link. So these are very simple things that, for a single developer using it, not very important. If I can attract a little bit of community interest, then that would be a vital tool that's needed immediately. But without community interest, it's not really something that's worth pursuing. So the jar inspector, that's very simple. You can just get the manifest entries from the jar, display them the same way you would in Eclipse or IntelliJ, and just view what's in the jar, pop something open, view the source. Maybe you want to unzip it, make a change, see what happens when you recompile it. That last one actually says git webhooks, so that's pretty simple. That goes with the JGit support. So the main use case that I'm using this for now is local development platform. So I don't have to use the collaborative tools to be able to leverage the fact that I have a GWT recompiler and a pluggable system to be able to automate my builds. So I'm looking at this in terms of actual company use where, once again, if you have the experts who know everything, you don't want to pay them to train the new hires who don't. Pay them instead to build tools, give those tools to everybody, and save yourself time and money, because especially time, that's the big one. The detection of common error states and suggesting known solutions, that comes with basically, weeks to months to years of experience to know, oh, I got this error message, I better do this to fix it. Once you can automate that process, you don't have to pay that learning curve for everybody. So there is the next level of use case, which is the remote development console. So once you've done all of these tools for your local development, why not add that to your CI site? So that way, when you're getting QA testing, a person can simply pop open ColliDE to view the files. If you're doing some code review and you want to see what that source code, what that change is, you can pop it open, have a look, make a change, recompile, essentially leveraging all of the tools you would use locally and just run them in your CI sites. So I don't really need to read this to you guys. I'm sure you can figure out the value in that. The next thing, however, is for any framework developers out there, especially people who are open source. If you're building a tool and you don't have an administrative console in your tool, it's very hard for people to know what your tool can actually do. If you have a demo, for example, and you want to show the source code, it's very nice to show the source, but imagine if you could say, go ahead and edit the source, recompile it, and have a look at the changes. So instead of just a read-only view of your framework, you can create a read-write view that actually allows people to directly play with it without downloading or touching a single piece of code. Well, you have to touch the remote code, but you don't have to download any environment. The environment can be set up on your remote site. If you have CPU cycles to spare, you can let them run full compiles, but with recompiles, it's very lightweight. I'm using a cheap VPS for mine, and it does work. So the basic idea here is, if you do have a process that you're trying to sell to somebody, rather than try to sell them with documentation and marketing, which you should do anyway, you can also give them powerful tools that they can visually see, oh, it can do that. Or when you add a new feature, you can have the little new thing that says, hey, by the way, now you can, fan out 10,000 tasks and we will figure out how to fan those back in for you. Anything that you can possibly try to automate, this allows you to distribute as well. So last but not least, if I can build a community around this and people do start building plugins, this allows everybody to share their plugins. So if you have this neat trick you do to parallelize your Maven builds or do dependency graph checking, you can add them as a plugin and get free community visibility. So not only will you have your own blogging and marketing, you can also leverage this particular community, which I hope sprouts from this talk, but if it doesn't, this is my hobby as well as, well, no, it's actually just my hobby, unfortunately. So anyway, this last one, I kind of went over it already. I should have kind of saved this, but the visual JUnit testing, the JUnit 4 support, if anyone has used GWT test case and know the pain of debugging a GWT test case, you will know why I have done this. If you've had to do window.alert to get your data out and see what's happening, and felt that horrible shudder when you're using window.alert, you'll know why. I was actually talking to Brian Slasinski, and he actually made this handy open source project, which does essentially the same thing I'm doing with JUnit 4, but for your GWT test case. So that's something you can use immediately for your debugging. When you have something go wrong, you can actually run it in a browser and have a visual representation and a debuggable, if you use draft compile, a debuggable source map integration test that you can play with yourself. So the GWT annotations goes with the JUnit support. I might actually be using that for regular compiles as well, but at this time, that's the only place I'm actually using it. So, oh, and last but not least, my XAPI framework is designed to be cross-platform. So any code that runs in GWT or the JVM, I want that service to run in both. So when there's something that can be put into GWT, it goes into GWT. If it can't, then it goes behind an asynchronous service so that the actual implementation lives on the JVM and the client-side implementation lives, obviously, in the browser. So when you write your unit tests for your JVM version and you want to run those same unit tests on the client, you don't have to write a single line of new code because it's the same unit test, it's just running in a different environment. So the framework actually swaps out the services that are being used, and this allows you to write a single test that covers both the real implementation and the browser level implementation so you can see where any bugs are. All right, so my roadmap. January is when I'm going to extract the recompiler. So look for it on the G+ community. That's where it'll be posted. By February, I'm going to start cleaning everything up to get ready for a new version increment because I was talking to the original team and it seems like no one else is picking it up, so I will be the sole maintainer. So by March, obviously, give it a month of community feedback for the RC version, and then release a new version. Once the new version is released, that's when I'm switching to Java 8, GWT master, and going with the JS interop and web components style GUI. So it's going to be bleeding edge stuff. Maybe they change something in GWT master and it breaks. No big deal because it's just a hobby, right? So if a person wants to play with these kinds of new features, you'll be able to just pull it down and have all of that ready to go with a recompiler. No setup needed, nothing you need to do, just pull it down and play with it. So the first thing I'm going to build with that is the server-side hot swapping because right now I still have to actually manually restart the server, as you saw seconds ago where I had to switch screens. That would have been very nice to show you that I just click a button and switch the server. So look for that in future presentations. Ninja mode, as I covered before, and then by the end of next year, I hope to publish ColliDE 2.0, which will have the actual full hot swapping and plugins for Maven and Gradle, everything that a person needs to actually leverage the tool immediately in your builds and start saving time and money. So links to the discussion, and that brings me to the credits with almost 20 minutes left. So I'm hoping there are a lot of questions. Any questions, perhaps? Any features that people would like to see? Yeah. Okay, so the question was about using plugins and having Apache Felix on the back end to actually use OSGI for the plugins. And the answer to that simply is I did not consider that in the current runtime environment because Vertex is not a standard Java EE container. But there's also another consideration in that there are server plugins and there are client plugins as well. So no matter what, you are still going to have to use for now, use the custom plugin framework that I built, but actually having Felix as a backend or any backend that you want is a good suggestion that I will undertake while looking at possibly removing Vertex. I don't want to have to reinvent any wheels, although I do already have dependency injection in my own framework, which is how I'm doing the plugin system. Essentially, you just add to the provider and it will use a service locator style lookup to look up anybody who implements server plugin on the server side. So thank you. Oh, I guess there are no questions. All right. Yeah, the presentation that will be available on the GWT community is going to be from Google Docs instead of the exported and viewed on LibreOffice version. So this is not how it looked 30 minutes ago, but I did not have time to fix my Linux video drivers, which, if anybody knows how that game is played, yeah, I'm just happy that it displays. So. All right.